Polynomials can be written in either of two forms. The first is standard form. The second is factored form. This lesson will explain how to convert a trinomial, that is a polynomial with three terms, from standard form to factored form through a process called factoring. The learning target for this lesson is I can factor trinomials in the form of x squared plus bx plus c. Our lesson will focus strictly on trinomials. That is a three-term polynomial. In this case, the trinomials will be written in standard form. That is, the degree of the terms is continuously decreasing from left to right. Our first key idea is that some trinomials of the form x squared plus bx plus c can be factored into equivalent forms that are the product of two binomials. Let me give you an example. If I have the trinomial x squared plus 5x plus 6, I can write that trinomial, which is currently in standard form, in another form called factored form. The factored form would be x plus 2 times x plus 3. According to the key idea statement, these two forms are equivalent. Consider if I use a value such as x equals 2 and substitute that value into each of the different forms. For example, if I place x equals 2 or substitute x equals 2 into the trinomial, then I would have x squared plus 5 times 2 plus 6, which is 4 plus 10 plus 6, which has a sum of 20. Now notice that if I also substitute 2 into the binomials, then the first binomial would have a value of 4. The second binomial would have a value of 6, or 5 rather. And if I multiply those two binomials, 4 times 5, I also get 20. Notice that the value of each of these expressions when x equals 2 is 20. These two forms are equivalent forms. Another way that I could demonstrate equivalency for you is to take the two binomials, x plus 2 and x plus 3, and multiply them back together again. When I multiply these binomials, I should have a product of the original trinomial. Let's see if it works. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. When I add my two middle terms, I do have a product of x squared plus 5x plus 6, which is the original trinomial. Again, the binomials that are being multiplied together are equivalent to this trinomial. Or I must say that the product of the two binomials is equivalent to the trinomial in standard form. Now the second key idea is going to help us with our factoring. It says that the signs and factors of the coefficients of the trinomial indicate how the trinomial can be factored. The trinomials that we are going to be factoring are in the form of ax squared plus bx plus c. We will designate a to have a value of 1. Therefore, I could look at this and say what I'm really factoring are trinomials of the form x squared plus bx plus c. Because since a has a value of 1, the coefficient of the first term will always be a 1, which I'm not actually showing in my multiplication, but I could if I wanted to. Now, in the original problem that I gave you in key idea number 1, x squared plus 5x plus 6, which is circled in red here, notice that the sign of b is a value of 5, and the sign of c, which is 6, both of those are positive. Because if I consider x squared plus 5x plus 6, then b has a value of positive 5, and c has a value of positive 6. When both of these values are positive and I factor, then the two binomials will be sums, like so. The signs of B and C, here and here, indicate that the signs of the two within the two binomials are both positives. That is, we have a sum, a binomial sum for both of these. But consider what would happen if I changed my sign of B to a negative. Now, B has a value of -5, whereas C has a value of +6. How would that change my factoring? Well, what it would do is it would change the signs of the binomials to subtraction signs, like so. What I guess I'm trying to say to you is that the signs here of the coefficients of the trinomial, that is the sign of B and C, is going to help us to determine what the resulting signs of the factored form are going to be. And so today in this lesson, I will be showing you how to do just that. Let's try this problem just to illustrate how we could use these ideas that are being put forth in this lesson. The area of a rectangular solar panel is given by the trinomial x squared plus 7x plus 12. So consider the problem. We have a rectangular solar panel, and we are told that the area is given by a polynomial x squared plus 7x plus 12. Now remember that area can be found by taking the length of the rectangle and multiplying it to the width. So the entire area, x squared plus 7x plus 12, can be found by multiplying the length to the width. Now remember also that length and width can be referred to as base and height. So another way to write this would be that the entire area is equal to the base times the height. Well, they give me another piece of information in the problem. The height of the solar panel is x plus 3. Which means that in this statement, I can replace height with x plus 3. And what that tells me that I'm looking for is, well, what is the base, or what is the length, if the area is x plus 7x, x squared plus 7x plus 12. Notice now that we're thinking about this in terms of a standard form trinomial, that's this one, versus a factored form, that's this one. And we just need to know, well, what is this other factor? So let's just think about it. I know that x times x would give me x squared. What number should I put here so that if I were to multiply it by 3, I would get the 12? Well, that number really is a 4. And since both of the signs here are positive, that tells me both of the signs within my binomials are also going to be positive. Let's check and see if when we multiply x plus 4 times x plus 3, if we get back the original trinomial. In other words, let's test and see if this might be the answer. So x times x is x squared. X times 3 is 3x. 4 times x is 4x. And 4 times 3 is 12. And when I add my two middle terms, I get x squared plus 7x plus 12, which is indeed the original area that I have here. So did I figure out what the length was, or at least what the expression for the length is of the panel? The expression of the length of the panel would in fact be x plus 4. So a common place that we see factoring in our application problems is going to be when we're working with area and volume. And the reason for that is because area and volume are usually determined or are determined by some sort of multiplication. And that's exactly what factoring is. It's taking a trinomial and writing it in terms of two binomials that are being multiplied together. Again, the standard form of the trinomials that we are going to be working with is ax squared plus bx plus c. Keep in mind then that whenever I write a trinomial, such as the one that I used previously, x squared plus 5x plus 6, that I can designate the values of a, b, and c. In this case, a is going to equal a 1, b is going to equal a 5, and c is going to equal 6. Because a is the coefficient of the first term, b is the coefficient of the second term, and c is my constant term. So let's choose another quadratic trinomial, and let's designate its values of a, b, and c. Maybe I'll have a quadratic trinomial such as x squared minus 4x minus 12. In this case, my value of a is still 1, my value of b is negative 4, and my value of c is negative 12. So to begin factoring, we're going to be factoring trinomials where the value of b is greater than 0 and the value of c is greater than 0. So in other words, b is going to be a positive number and c is going to be a positive number. So look at our first trinomial, x squared plus 8x plus 15. Let's factor that. Factoring involves asking yourself the question, what factors are possible for 15? In other words, what numbers can I multiply together to give me 15? Well, the first pair of factors is 1 times 15, and the second pair of factors is 3 times 5. And those are the only factor pairs that multiply together to give me 15. So when I multiply my binomials, I know that the last two numbers, here and here, would either have to be 1 and 15 or 3 and 5 because they have to multiply together to give me the 15. I know that the first two parts of my binomials will have to be x and x because x times x gives me back x squared. So I ask myself the question, of the pairs of numbers that multiply together to give me 15, which pair would also add to give me positive 8? Well, 3 plus 5 is positive 8, so I'm going to say that this number is probably a 3 and this number is probably a 5. And it doesn't matter whether I put the 3 or the 5 first or second. They can go in either place. So I also could have written this as x plus 5 times x plus 3. Either one of these would work. Because remember, with multiplication, the commutative property of multiplication says that it doesn't matter which order that we multiply in. Okay, so now I'm going to check my answer. So we're going to FOIL x plus 3 times x plus 5 and see if in fact we do get the trinomial back again. So x times x is x squared plus 5x plus 3x plus 15. And my two middle terms do in fact add together to give me x squared plus 8x plus 15. Let's try another one. Again, we're using b is greater than 0 and c is greater than 0. So in other words, the value of b should be positive and the value of c should be positive. This lets me know that when I factor this trinomial, that both binomials will also be positive. Now, look at the trinomial that I'm trying to factor. R squared plus 11r plus 24. R squared would be r times r. For 24, I need to list the factor pairs of 24. I usually try to create what's called a systematic list. I start with 1 times 24 and start working my way up from there. The next number up would be 2, and 2 times 12 is another pair. The next number is 3, and 3 times 8 is another pair. Then 4 times 6. 5 does not have another factor that when you multiply 5 times another number, you can't get 24. And since 6 is already listed here, I know I'm through making my list. So now what I'm looking for is out of these pairs of factors, which would add together to give me 11. And if I look at these pairs, the two that would add together to give me 11 are 3 and 8. So that tells me that one number will be 3 and the other will be 8. Now remember, it doesn't matter whether I put the 8 first or the 3 first. So now what I'm going to do is I'm going to check my answer by multiplying back to see if I've got the right result. So multiplying back, I get r times r is r squared plus 8r plus 3r plus 24. So that is r squared plus 11r plus 24, which is the original trinomial that I started out with. So that tells me that my factoring is more than likely correct. Let's try another one. This time I'm going to change my value of b to a negative. So now b is going to be negative while c is going to stay positive. So my factoring pattern is going to change a little bit by doing this. Again, let's factor x squared minus 11x plus 24. Again, I take the numbers 24, or the number 24 rather, and I write its pairs of factors. Since this sign is positive, I'm still looking for two numbers that add together, but this time I would like for them to add together to give me a negative 11. Well, in order for that to happen, both of them will have to be negative. So when I write this down, I'm going to break the x apart into x times x. And I'm going to look at my pairs of numbers, and I'm going to choose a pair that add to give me 11. Well, 3 and 8 add to give me 11. But in this case, both of them will have to be negative because in actuality, I want them to add together to give me negative 11. And this is the way it should work. So let's multiply back to see if we've got the correct result. So x squared minus 8x minus 3x. But then notice that negative 3 times negative 3 is positive 24. So when my c value is greater than 0, that is, it's a positive, I'm still looking for numbers that add to give me the middle number, 11. But they will both need to be negative so that the middle term will be negative. And in fact, I do have the right result. So my answer then would be x minus 3 times x minus 8. Let's try another one. Again, I'm using the same values of b and c. I want b to be negative and c to be positive. And I would like to know the factored form of y squared minus 6y plus 8. So again, I'm going to put down my two parentheses, and I'm going to split my y into y times y. But I'm looking for two numbers that are going to multiply to give me 8, but I want them to add to give me 6. But since the 6 needs to be negative, both of these numbers are going to have to be negative. The negative times the negative here would give me the positive, which is here. So again, the negative times the negative will give me the positive, which is right here. But when I add these two negatives, I'm going to get the negative that's on the 6. So which of these two numbers have a sum of 6? Well, 2 plus 4 is 6. So I'm going to put the 2 here and the 4 here. And then I'm going to test to make sure that I did get the correct factoring. So let's multiply it back together. Y times y is y squared. Minus 4y minus 2y. That's what gives me the negative 6y in the middle. Then the negative times the negative gives me the positive. So I can't stress that enough, that that negative right there and that negative, when multiplied, give me that positive. That's why they both need to be negative. Then when I combine the terms in the middle, I do come back out with what I originally started out with in standard form. So y squared minus 6y plus 8. Again, b is less than 0, so that means it's negative. C is greater than 0, that means c is positive. Let's factor that. We've got x squared minus x plus 2. I'm going to go ahead and put my parentheses down and split my x's apart. X times x. I need a pair of numbers that gives me, multiplies to give me 2, but they're going to add together to give me a negative 1. Well, so I look at these and I think, well, if they've got to add together because this sign is positive, right? But they have to add to give me a negative 1, and these two numbers don't do that. So in this case, I would have to say that this cannot be factored. So not every trinomial that you encounter will be able to be factored. Some of them cannot be factored. So you can just write down it cannot be factored and you can leave it alone. Okay, let's try another one. Notice now that I'm going to change my value of c, and I'm going to let c be less than 0. That tells me that c is going to be negative. So if you look at my trinomial, x squared plus 2x minus 15, the trinomial is a negative. Excuse me, not the trinomial is a negative, but my c value is negative. When c is negative, it's going to change the way I look for my pair of numbers. So I'm still going to follow the same procedure. I'm going to split the x apart into x times x. But when I write my pairs of numbers that give me 15, instead of looking for two numbers that add to give me 2, I'm going to look for two numbers that subtract to give me 2. So if the sign here is negative, that tells me that the two numbers that I need to subtract to give me that positive, to subtract to give me 2. So when I'm looking at my pairs of numbers, I immediately notice that 3 and 5 subtract to give me 2. So that tells me that the two numbers I'm looking for are 3 and 5. Well, another way to look at this is that they're going to add to give me a positive 2, and that one would have to be positive and the other would have to be negative. So if I look at these and I say, well, they're going to have different signs, because the only way for them to multiply to give me negative 15 is for the signs to be different. Which one of those two would need to be positive so that when I add them together, I would get positive 2? Well, the one that would need to be positive would be the 5, because positive 5 and negative 3, when added, give you a positive 2. Let's multiply back and see if that's correct. So I would have x times x is x squared plus 5x minus 3x minus 15. Notice that since one is negative and one is positive, that when they multiply, they give me the negative 15. That needed to happen. Notice that since this is a positive 5x and this is a negative 3x, that when I add them, I get positive 2. So x squared plus 2x minus 15 was my original trinomial. And by multiplying back, I just checked, and this is correct, the correct factored form. So to wrap this up, let's remember that some trinomials of the form x squared plus bx plus c can be factored into equivalent forms that are the product of two binomials. For example, x squared plus 5x plus 6 is a trinomial that is in standard form, and it can be factored or placed in factored form as a product of two binomials, x plus 3 and x plus 2. Now remember that the signs of the standard form trinomial, that is the sign of the b and the sign of the c, will help us to determine the signs of the two resulting factors in factored form. If both b and c are positive, then the two binomials will be sums. Contrast that with this. If I have x squared plus 5x, but then my c term is a negative, maybe a negative 14, then the signs are going to change in my resulting binomials. I will still have x times x, but two numbers that multiply to give me 14 but have a difference of 5 would be 7 and 2. So notice that how I figured that out was that I looked at the number on the end, the 14, and said what two numbers would multiply to give me 14 but subtract to give me the 5, and that's 7 and 2. Then I have to figure out which number will be positive and which number will be negative. In order to have a positive 5, I would need for the 7 to be positive and the 2 to be negative. So again, the sign of C and the sign of B will determine the signs of the resulting binomials, whether they're sums or whether they're differences. If I have a case of x squared minus 5x plus 6, remember that because the C value was positive, that told me that the signs were the same. And the value of the b was negative, which told me both signs would be a negative. So the two numbers that multiply to give me 6, but add to give me 5 would be 3 and 2. But they're both just going to be negatives. I can always check my work by multiplying the two binomials to ensure that their product is equal to the original trinomial.